In this video, we're going to take our first look at Pygame. So Pygame is an open source multimedia library for Python. It's designed specifically for making games in Python. Now, open source means that you can read and modify Pygame source code if you're so inclined. You can change the library itself. We're not going to do that, but I do recommend going forward, take a look at some other open source libraries that are out there. You'll be surprised what's available for free. Now, in order to install Pygame, I use the following command, Python 3 if that's what you've been typing to run Python programs. So Python-m pip is the Python installer. It's Python-m pip install Pygame. So pip here it's Python's package manager. It's included with any version of Python later than 3.4. -m here just means run this package manager as though it were a program for Python. It can also be run standalone. Install is a command for pip to say to install a new library, and Pygame is the library that we want to install. So this will download and install the Pygame library for use in our code. So come to your terminal here and say Python-m pip install Pygame. And again, if you're on Mac or another system that has Python 2 installed as well, use Python 3 instead of just Python. So running this, you should get a bunch of walkthrough here. So now it should say successfully installed Pygame. And if we want to test that, let's make a new file here, pygame_demo.py. And in here, we're just going to say import Pygame, and that's it. So let's run this file, Python Pygame demo. And there you go. So it installed Pygame version 1.9.6, and we can see that it seems to be running. Hello from the Pygame community. Okay. Now, if you have any trouble getting this installed, if you have, for example, a permission denied error, if you're on Windows at least, you might need to run PowerShell as an administrator in order to have installation privileges. But if you have any trouble whatsoever, come stop by the Discord and we can get you set up properly. Now, the documentation link for Pygame is at the following link, pygame.org/docs, I believe. Now, reading documentation is an important skill to develop in computer science, so I highly recommend any new language that you come across or that you're trying to learn to take a look at the documentation, see what's available, see where to find information. Don't read through it. It's a bit like reading through a dictionary, but understand how it's all laid out so when you do need some information, you know how to find it. So we're going to actually do that for Pygame a little bit here. So there's lots of useful stuff in Pygame, but we're just going to mostly stick to this top row here. So color, draw for the shapes, events we're going to take a look at later on. I don't think we'll get to any of the images or any of those, but there's lots more stuff available as well. All right, so let's start by just opening and closing a Pygame surface. So to open a screen in Pygame, first we have to import the Pygame library as we've done, and then we can open a drawing surface by using the following command, pygame.display.setMode. Right, so it has lots of optional arguments for setting full screen or OpenGL or resizable windows and all that. We're just going to stick with the basic width by height window. So W here is the width in pixels for the new window that it will open, and height is the height. Now, the argument for this set mode method needs to be as one data structure. So you can use a list as I've done here, or if you want a tuple, so around brackets, it's just a combination of those two values as a single data structure. So let's add this into our program. So we have import Pygame. Let's say let's create some system variables. Screen width equals 800 and screen height equals 600. Now, the reason we're creating those as variables is in case we want to run this in different sizes. Anything that's dependent on the screen width and height, for example, if later on we want to have something happen near the middle of the screen, we don't want to use 800 divided by 2. We want to use the variable screen width divided by 2. That means we can change the size of our screen, and everything relative to those variables or these values will change along with it. So screen width, screen height gives us constants that we can deal with while we're running our program, and those create our screen. So pygame.display.setMode. And then we're going to pass in the width and height as a list. So list screen width, screen height. All right. And now if I run this, it's just going to close right away. So let's just put in an input here to pause execution. We'll say press any key to exit. This will just pause the execution. As you've seen, input waits for the user to do something, so when it hits this line, it'll pause there and we can see what's happening. So let's run our demo again. And we can see it opens up a window that's roughly 600 by 800 long. And now it's frozen here saying press any key to exit. So it's waiting for anything to happen. Now the Pygame window itself is kind of frozen. This isn't a great demonstration of what Pygame can do. We can see we've opened up the display. All right. Now if we click the X button or really do anything, this all crashes. So let's first learn how to make this Pygame window a little bit more responsive. Okay, I think that's in the slides again. So to close the drawing surface, we have to actually do a bit of event handling. We're going to talk more about events later on, but for now let's learn to handle the exit event. So while not exit flag, or you can also do the reverse of that, just while running. So this is just some variable we're going to keep track of to represent that our system should continue looping. So this is going to be our whole simulation loop is going to be tucked into this while loop here. But the first thing we'll do is check to see what events have occurred. So in the background, Pygame is keeping track of all the possible events that occur. It's things like mouse motion, keyboard strokes, clicks, window resizing, things like that. And included in all those is clicking the close button on the Pygame window. So what we're going to look for is finding an event of type quit, so pygame.quit. If that's the case, then we're going to set this exit flag to true, which will make this while loop false and break out of the simulation. So let's add this to our program. So instead of press any key to exit, let's create an infinite loop. So we'll say exit flag equals false, while not exit flag, and then check for exit events. So ev equals pygame.event.poll. So this is asking what's the most recent event to have occurred, Pygame, and it will tell us, well, here's an event, ev. Now if ev.type, so ev is an event object which has an event or a type attribute, and there's a bunch of different types. We'll talk about those when we talk about event handling later on. For now, one of them is of type pygame.quit. So this is a value created inside the Pygame module that just represents what it means for a quit event. I actually think it's just a number. Okay, and then in that case, if we do have a quit event, exit flag equals true, we'll say set this flag so that this loop will then break. So it comes back up and asks, is exit flag not true? It is true, so that's false, and the whole thing breaks and we end our loop. Now, this is using what's called a busy loop. Let's just run this for now. So a busy loop says just keep checking a thing over and over and over again. So we can move our window around, no problem. A busy loop is just checking over and over and over again this one thing. And it's just going to keep checking and checking and checking until we actually click the close button, and then it exits. So the event.poll asks Pygame if any event has occurred. If nothing happens, that poll will return a no event. But when a quit event occurs, then we can see that. So actually, we can take a look at this. Instead of just polling, let's print ev.type. Okay. There we go. So as this is running, and this is actually continuously spitting out zeros, so I can't actually scroll to the top of all of them because they're spreading out so fast. But eventually, let's just close the window and scroll to the bottom here. So a whole bunch of zeros, and then it ended with a 2. Or sorry, a 12. So 12 in this case represents the exit event. 0 would be no event is occurring. When we get a 12, so when the type of our event is pygame.quit, which is just a storage for a specialized 12, then the whole thing exits. So when we get that quit event, we set the exit flag, and then break out of our loop. Okay. So this gets our simulation window open, or our Pygame window open and closing. So now let's see what we can put into this. Before we can learn to draw, though, we have to learn about colors. So RGB colors is the system being used by Pygame to represent all kinds of colors. So a single color is represented as a combination of a red channel, a green channel, and a blue channel, where each of these is just a number between 0 and 255. So red, green, and blue is just 3 different numbers in that range, and then combined create the various colors. So here's a table representing how some combinations work. So for example, if all 3 values are at 0, then we have black. It's just the absence of color. And if all 3 values are at 255, then we have white. We have the maximum color. Now, the color combinations might seem a bit odd because green is not normally a primary color, but when we're dealing with the colors of light, these are the three primary colors, and the combinations work as follows. So if we want to have, for example, an orange, that's red with some green. If we want to have purple, that's blue with some red. And if we want sort of a tealish color, that's green and blue. So combinations of all the various different channels of different amounts gives us all the possible different colors. Now what this means is we have 0 to 255 in each one of these, which means we can represent each channel as a single byte, because we can represent the numbers 0 to 255 in a single byte, which means we have 1 byte per channel or 3 bytes per pixel on the screen. So we can represent a color with 3 bytes, or 24-bit color as it's sometimes referred to. Now, one last thing to point out, when we're dealing with color in programming, it always uses the American spelling. Generally speaking, there's no U in color in a program. Now, in this specific case, this would be a variable name. You can use U in your own variable name, but I recommend not bothering because you're going to confuse yourself when you try to use, for example, a pre-built color method. It won't work if you call the color method. So with this in mind, let's do some drawing a little bit. Let's use color in our screen. So the first easiest thing we can color is filling things. So let's do a screen.fill. So if we want to fill in the entire background, screen.fill and then some color. So screen is this thing that we got when we opened up the window. So that's that drawing surface that we saw. And let's just add this into our loop. So we'll say screen.fill. And then let's just pick some random colors. So 255, 128, 0. So again, that's R, G, and then B. So a lot of red, a little green, no blue should give us something roughly orange. But experiment, play around with the different numbers to find a color that you like yourself. Okay, so save and run. Right, so we ran it, but we didn't actually see anything. So one of the issues here, or the issue that we're currently experiencing, is known as flipping the buffer. So we can fill the screen with screen.fill, but if we want to see it, we need to flip that buffer onto the actual screen. So the drawing that we're doing is not to the screen itself, it's to the screen's buffer, and then we want to actually see it, we need to flip that. The reason for this is that once the simulation gets pretty complex, the drawing can actually take quite a bit of time. Having a buffer ensures that we don't end up displaying half-drawn scenes. So you can think of it like a two-sided paper or a two-sided chalkboard. We're going to draw on the one side while displaying the other, and then when we're done our drawing, we'll say flip that buffer so that the back side that we were drawing on now becomes the front side. And now the previous front is the new buffer, and we can modify that to be drawn for the next frame. So having this buffered writing, it avoids screen tearing. I don't know if you've ever tried to watch a high-definition movie on a very slow laptop. You're going to see a whole bunch of scenes where if there's a lot of action, the top half of the screen will be the next frame and the bottom half of the screen will be the previous frame. So having buffered drawing in here is going to prevent that kind of screen tearing. So let's add that into our demo as well. We do screen.fill, and then we could have pygame.display.flip. Okay, so let's close this and rerun it. And now we can see our color. So we got an orange color there. If we want, we could maybe add some blue into there as well. Let's do 200 blue. It's going to make it pretty bright, so let's make this down to 55 red. So that's our previous color. Let's run it again. And we get a blue color. Right? It's mostly blue, a bunch of green, and no red, or little red, so we get some sort of shade of blue. All right. I recommend creating a template file for these sorts of things. This represents the basic things that you'll need to do in order to create a Pygame screen. So if every time you want to create a Pygame program, you have to remember to type all these things, it could be a bit of a hassle. So if you take this demo as it is and save it as a template or something that always keeps it at the top of your folder, it means you'll be able to find this template, copy it into your new program, and then start from there instead of having to start from complete scratch. All right. Next, we're going to start drawing some shapes, but before we do that, I need to discuss this window a little bit. So let's actually open up, I have a whiteboard tab here. I'm just going to draw a square representing that window. So this is this canvas here. And actually, hang on, let's make it a bit more square. less square, I guess. There we go. So at the top left corner of this, so up here, up on the screen, we have what's known as the origin, or 0, 0. Okay. Now the x-axis goes this way. That's our x-axis, and this is in the positive direction. Okay. And this, whoops, this here is the y-axis. Excuse my handwriting. And this goes in the positive direction downward. Okay, so the bottom left corner here, since we made our window 800 by 600, this would be the point 800, 600. There we go. And then, for example, if we wanted the midpoint, that would be around here. That would be 400, 300. Something like that. Okay, so 0, 0 is in the top left corner. If we increase the x-axis, we go to the right. That's kind of normal. If we increase the y-axis, we're going to go down, which depends on your drawing program sometimes. So with Pygame, positive y is down, negative y then would go up. So if we're at this point and we say this point minus some values, we're either going to be going left or up, or both. Okay. So with all that in mind, let's take a look at some of the drawing primitives in our new Pygame library. So the simplest shape to draw is a line segment. So all the shapes are inside this pygame.draw submodule. So pygame.draw.line. It gives us the ability to draw a line. So the line is a function, takes in the screen, which is the drawing surface we've been using, some color, which again is a triple RGB, and then a start point and an end point. So x1, y1, x2, y2. Now again, I've used lists here. If you prefer, you can use tuples. If you're reading through the documentation, they use tuples there. The reason being tuples are a little bit more lightweight than lists, but either one will work in this situation. So that is square brackets or round brackets here is fine. Now, pygame.drawLine, screen, color, start point, end point. So let's create that in our demo. Let's see what a line looks like. Let's close this one and come to here. So we have a line. So before the flip line, we'll say after the background, because Phil is going to put everything in the screen to this one color. So if we do that last, it's going to destroy anything we draw. So somewhere between fill and flip, add in this line here, pygame.draw.line. Now we have to pass in a screen, which we've called screen in this case. That's our drawing service. We need to pass in a color. So let's do a white line, 255, 255, 255. So max of all three channels gives us a white color. And let's draw a line from the top left corner, so 0, 0, down to the middle of the screen. So we'll say screen width divided by 2. Let's do integers. And screen height divided by 2. All right, save and run our code. And there you go. We have a white line going from the top left corner right to the middle of the screen. All right. Next shape up, let's see how we can draw rectangles. I think that was also on the same page. So a rectangle, pygame.draw.rect. That takes in a few pieces of information as well. So a screen again, a color. This is the outline color for our rectangle. And a tuple of information that contains the start location of our rectangle and the width and height. So X and Y here is the top left corner of the rectangle. The width is the number of pixels across, and the height is the number of pixels down from that point. So going back to our drawing here, if we're drawing a rectangle, it's very similar to how we're drawing our screen. X, Y is this top left point, and the width and height are how far down from there we want to draw. So let's close this and come back to our code. So let's draw a rectangle in here. Pygame.draw.rect. Pass in the screen that we want to draw it on, and some sort of color. Let's just draw a red rectangle, 25500. So all red, no green, no blue. And then we need an X, Y, a width, and a height. So we'll say, let's draw from 100, 100, and a width of 50 and a height of 25. So that's at the location 100, 100, so 100 pixels from the top and 100 pixels from the left. It's going to be 50 pixels wide and 25 pixels tall. Save, run our code, and we can see exactly that. So it's wider than it is tall, and it's roughly 100 pixels in 100 pixels. So the top left corner is here, then 50 pixels across, and 25 pixels down. All right. Now there's lots of other things we can draw, like for example a circle or a triangle. Let's take a look at the documentation. So pygame.docs.orgs. Oh, I have to reinstall PowerPoint for some reason to do that. Right, so in the documentation here we have all sorts of things. The shapes are under pygame.draw as we've seen. And here's a whole bunch of things we can draw. So rect, polygon, circles, arcs, ellipses, and all sorts of things. Let's start with a circle. So this gives you a quick rundown of what we can include here. So this is the default version that we've been using. So it requires a surface, a color, which is going to triple the values, red, green, blue, a center, which is an X and Y location, so that will say that here, a tuple, int or float, comma, int or float, or a list, int or float, int or float. So you can use square brackets or round brackets, and you can include ints or floats, and there's two values we need to include. So an X and a Y value. Okay. So that represents the center of our circle, and then a single value radius here, which is either an integer or a float, measured from that center parameter. So unlike a rectangle, the XY we're providing is not the top left corner, it's going to be the middle of the circle. From that point on, we're going to draw the line radius pixels away from there. Now, optionally, you can include this width argument that allows a thickness of the line. So instead of just being completely filled, like we saw with our rectangle, it defaults to 0, is just filled in. If we provide a width, then a positive width at least, we get a line thickness, and then the inner spot, it looks more like a ring than a circle to that regard. Okay, so let's try this out. So we want to draw a circle. Let's go to here and close this, and go back to our code. So, a circle here, pygame.draw.circle. Let me pass in the screen. We need to give it a color. Let's do a green this time, 0, 128, 0. An X and a Y location, so let's make this 600 by 400, let's say. Oops, sorry, that should be in a square. So a center location for our circle, and a radius, we'll make it 50 pixels. Okay, and close this and open, and there's our circle. So down here, so the center point, the XY we provided, is right in there, and then the radius is 50 pixels around. Good. All right. So that gives us the basics of Pygame. In the next video, we're going to take a look at animating all these things, as say getting some motion on our screen. All right, I'll see you then.